take 2 milliliters of citric acid. Citric acid is C6, hopefully, H8O7. This one is sodium hydroxide. Anything is sodium? Bicarbonate sodium. I want this to be level. So I'm going to try to get it as flush as I can. I think that's. It says I'm going to dissolve 1 level 2 milliliter spoon into this. I believe it says 1, but it does say 2. It says 2 spoons, so they're different spoons. Okay, gotcha. Not sure if it tells me.
No, you put the NaCl on not sodium bicarbonate.
Put 1 2 tablespoon of sodium bicarbonate into the bottle. So here we go. Flour scoop this the way I see on the cooking channel. It works for the cooking channel. And cooking is science.
Marvelous.
Yes. I love that. Oh, yep. Almost messed up there. That's why we made a funnel. Dun 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 dun. Prince Ali. It's not a very good funnel. Come on, funnel guy. Oh, I'm gonna have to edit this video so much. Oh no.
Okay.
Pause. Inset him. And then I'm gonna push, right? Push. It goes to 10. Well, the little nipple guy actually goes to 5, 6, 7, 8. Yeah, so the end of the little plunger is at 8. Pretty cool. So, 8. I'm guessing that's just volume of gas produced. 8 milliliters. Alrighty. Trial 2. There's my funnel. Perfect even scooper. to use this guy. I think it's gonna be easier for you. That's really good. I'm actually so proud of her. I'm gonna make this one better. She was having a hard time. And it's still too good for you to hold. Alrighty. 5 milliliters of this guy. I think that's about right. Yep. Pretty good. Just be sure to check out that. Alrighty. And they go. And bam. It didn't go as high this time. Kind of stayed at 5. Maybe 6. Okay, stay at 5. 3. Trial 3. Oh, governor. Trusty funnel. Ah. 5 milliliters. Measure really well. Cap goes on. Trial 3. And she goes. I wonder why it was so high the first time. It's making me think I did something wrong. Oh, what a world. What a world. Questions. What caused the syringe plunger to go up in during the reaction between citric acid and sodium bicarbonate? I think that was a release of gas. Why is a syringe more useful than a balloon to conduct this experiment? Because you can actually measure the amount of gas released in a syringe compared to that of a balloon. What do you think might happen if you double the amount of citric acid solution? I was talking to my partner about this as well, and I think if we doubled it, then we would get bubbles acting at a faster rate, so faster bubbles. Why? Because there'd be more oxygen to react with the bicarbonate. And that goes into my number 4, which is what do you think would happen if you doubled the sodium bicarbonate? And I think that would make the bubbles last longer. And that's because there would be more bicarbonate to react with oxygen, I think, maybe. So what did you learn about the air using the 2 syringe system? I learned that air takes up space and has a volume, and that volume, when is pushed to the second syringe, takes up the same amount of space. A great way to show kids that air takes up space, right? What did you learn about air with a syringe system that was clamped shut? I learned that it is equal on both sides. Yeah. Why couldn't the plunger be pushed all the way down? Well, when we try to push ours all the way down, it's kind of just stops, right? When you keep pulling down on your plunger, there's the air kind of is pushing it back up against it. So there's like a repulsion effect to an extent.
Does air take up space? Yes, I think that this is a great way to show that. And does air always take up the same amounts of space? In this lab, yes, because it's the same amount of air when you originally pull back and then push it to the other side. But I don't think it takes up the same amount of space in all situations.